back to another video. Let's talk about the co-location. So what is co-location? Co-location or colo is a renting space in a data center to store your company's servers, networking equipment, and other hardware. So basically, you could have heard a word called as a colo racks. So these are the racks. So there will be one rack, and within that one rack, you are just renting the space for some half a rack, and this will the you can deploy your own devices over here, or you can get rent the devices from the provider itself. It's up to you. But basically, you are renting some space in it within a data center, and all the electricity and high availability options will be looked after by the provider because we are paying for that one. Now, co-locations allow you to outsource your data center need to the third-party provider who will manage the physical infrastructure required to keep their equipment up and running. Co-location hosting is highly secure data center facility. Definitely, this is hosted in the data center, so that will be highly secure, where equipment, server space, and bandwidths are available for purchase to business. Now, the traditional architecture method for optimizing traffic, such as load balancing, security policies, and WAN optimization, relied on centralized various elements like firewall intrusion detection prevention system, data leak prevention system, URL filtering, proxies, and other devices at network. Aggregation points. Aggregation points means then again you do have your core switches, which will be acting as the aggregation points, like all the your distribution what do we say, the distribution space, the layer 2 space. So these are all the tires connecting to a different segments or the tires, and the distribution will be connecting to the cores, and this will become as an aggregator router connecting to your outside world. Now, this approach required backhauling user traffic from remote site to maintain data centers for software as a service application and internet access, which increase application latency. For example, you do have a different site. So now this is your aggregation. This is your branch one, which is connected over here now. People are using. There is also a branch 2 people are trying to reach, but first it has to come to this core, then from here it will go to the Office 365. So they will have some latency because branch 1 has a direct access to the Office 365 with less latency, but branch 2 should have come to their service provider, then to your core, then to the Office 365. That increases the latency and the user experience, affects the user experience. For application hosted in data center, this method could lead to inefficient use of data center bandwidth resources because direct Office 365 is hosted on the cloud. They can go directly via the internet and save the bandwidth going towards the data center where you have your own critical applications which can be used for to access that one. Additionally, centralizing these elements made it challenging to effectively mitigate security incident. Again, since this one is coming via the service provider, so we are not sure how secure is the service provider. Again, we need to come up with a mechanism to make sure that the traffic is again encrypted. So complex configuration will be there. Now, challenging to effectively mitigate the security incidents such as virus outbreak, malware exploit, and internally sourced denial of service attacks. So let's take about the example of the virus. Again, branch 1 is being infected by the virus, so we are not sure that whether branch 2 is infected or not. And we do have like an headquarters, again that headquarters is being affected or not. So it's very difficult to track where that virus has been spread across your network. Now today, as we move into the era of the SD-WAN, the problem is exacerbated by the architectural shift. So we are now shifting from the traditional to the backhaul access, distributed access, or the regional access. Okay, so we already discussed about the regional, like in the policies, where the local sites should be taking the local data center within their own regions. Now, SD-WAN distributed access, this can be a mix of the cloud SD-WAN and the traditional also. Now, branches and users are now free to access software as a service application via the internet resource directly, bypassing the aggregation point. So we are now not we are bypassing the core one. So we do have a core which is connected to the internet, and we do have a branch one here which is connected directly. Now branch 2 is connected via the ISP to the core. So instead of accessing Office 365 via the core, now we are sending traffic directly, which is much more efficient. While this provides a much more efficient method of moving data from point A to point B, it poses challenges to IT team looking to maintain their traditional optimize and security policy. Again, it depends on the organization how the security is been in place, and that will also be affected because when you change some kind of topology, the security will also have to be changed. Now, in addition to the challenges with the previously listed, the following items also create pain points for many customers. It becoming increasingly difficult to apply optimization policies uniformly across private and public clouds. Again, different clouds work differently with different policies in place, so there is no uniformly policy across those clouds. Some IaaS and SaaS vendors simply do not provide the necessary optimization and security policies sought by your IT teams. Those IaaS and software as a service providers that do offer optimization and security policies typically do so in a way that is not consistent with your enterprise policies. Ultimately, there exists an inconsistency in the application of policies across user, device, application, and cloud resources. So it's just like you all not every time all of the companies or the providers will be on the same table. Definitely every organization and the provider will have their own security and their own policies in place, and in order to make that uniformly it's not possible because everyone has their own business. Now, Cisco SD-WAN supports both centralized and distributed architecture. So SD-WAN is the one, Cisco SD-WAN is going to resolve the problem for you. And it uses the service insertion policies and intelligently routing to direct traffic according to policy needs, leading to the concept of regionalized service chain. So if you remember that we have done the service chaining like in the data center one, we do have a firewall. And when we are trying to communicate with the branch one to the branch two, we said that go to data center, go to firewall, then come back and go to the data center. So it's like inspecting the traffic is being inspected over here. Now the same policy, same thing will be applied over here. The only thing is that this is a co-location. That means instead of having into your data center, doesn't it is not necessary that it should be in your data center. The data center you can host it virtually somewhere like a co-location site. So in a third-party data center, you will host your own rack, which is known as a colo rack, and you will install all your devices over there. So now instead of sending to data center one, now you will send the device to the colo rack. So using the Cisco co-location, this is where you will connect because they do have a specialized devices over there to connect to your SD-WAN fabric. You might have switches and servers over there. And once you're connected to those switches over there, at the back in that, you can install the different devices like your firewall, like your IDS, like your IPS. So these are the different security devices you can install at the back of the devices of the colocation devices. So doing the same thing, service chaining, sending the traffic via the firewall. Now you're sending to the colo rack. Over here it will go to the firewall maybe, IPS maybe, or the IDS, whatever it might be the security device over there. It will pass through that security device, then it will go to the branch 2. Now the intention over here is that since different cloud providers have different policies, not security will not be meeting with our enterprise, or it might not be matching with our enterprise policy. So that's where you will need to come up with an idea where, irrespective of where the traffic is going, it should go via your security. It should be inspected via the security. Now with Cisco Cloud OnRamp for colocation, it can create strategic demarcation points between users and devices and their resources. So that's what it is doing now. By placing optimization and security elements strategically, regional service chaining, balance operation, cost, application quality, and security incident. Since this has been moved to the regional, that means the cost will be low. Okay. And also you have your own securities devices installed over there, and you're passing your securities via those devices. So that means you are meeting your own security policy. So you're not violating that one. You're maintaining your quality, you're maintaining your security visibility, and you're also maintaining your policies. Now Cisco SD-WAN will give you more information, like once you're connected to your co-location rack, it will give you more visibility in that one, because there is an inbuilt monitoring system in that one, which will give you a lot of data of how things are working. If there is any problem, it will raise an event or the logs over here. Now, choosing to move to a regionalized model with a service chaining comes with many benefits, such as security. Definitely, we can install our own security devices over there. Scalability architecture doesn't matter. If you want to increase your rack space, you can increase it over there because you just have to pay for it. Performance agility, definitely, because since that is going via passing through your firewalls or maybe your security devices, you are the one who is going to maintain that one, make sure that it is able to reachable all the time, means definitely it will be, the performance user experience will be good. Flexibility, again, it depends upon your colo rack with whom you are hosting. And cost saving, definitely, because you're just renting some space within a data center, so you're paying for that particular space and a space only. Now, why co-location? Co-location counters centers offers opportunity to rent equipment bandwidth. Again, the main thing is the bandwidth. So they do have a very high bandwidth with very low latency. So it's very good for the application user experience. Or the space in a secure public data center, providing cost-effective connections to various telecommunication networks and cloud service providers. So definitely, when there are like a third-party data center, so they are not only you, there are multiple organizations over there. So, for example, this is your organization, and there is some telecom uh, organizations also within the same data center. So, in order to communicate with those servers which are hosted on the internet, will be a very less latency. So, it will be easy for you to redirect the traffic via your security devices, then to your the applications over the telecommunications. A key advantages of these centers is that geographically coverage, so it's not only located in one place, they are located globally. So you can rent the space globally. It's up to you. Again, it depends how big your company is, so not every organization is able to host it globally. Now, users to choose facilities close to their locations for optimal access to public and private cloud resources. So, for a normal organization, for I am in Australia, so if it's my organization, I will be looking for the Colorax within the Australia itself. If I have my branches in like maybe in London or the New York, then I will look for the Colorax which are nearest to those locations. With solutions like Cisco SD-WAN and Cisco Cloud OnRamp for co-location, user traffic can be efficiently routed over a short distance to meet the nearest co-location facility, ensuring optimization, enhanced security, and high-speed transmission to its destination. So that's the benefit for it. So how things works now, establishing regional service chaining helps organization to maintain their optimization and security policies previously used in centralized architecture. So I will skip this one because it's all theory. You can read through that one. But the main thing is over here that you do have your own SD-WAN fabric and you do have your regional colo rack somewhere hosted over here. So in order to communicate from one device to the other side, you can just say that, okay, just go to the colo rack first, go to the series of these services which I have hosted over there, and go back to your servers where you have hosted maybe in some other region. So it all depends upon, it's like a service chaining. The only thing is that instead of as we saw in our lab that we hosted on our own data center, now we are just hosting the same services on the regional Colorax. The only difference is that the Colorax works in a different way, which has a different devices hosted over there. In order to connect to that one, definitely there will be a switches or some kind of device which will be called as a node. So we are connecting our SD-WAN fabric to that node directly, so that whenever they want to communicate with one branch to another branch, you can create a policy saying that steer the traffic, go to the colo rack, go to the series of your security devices and go back to the servers or go back to your sites. It's up to you. Now, this is how the devices look like into the Colorac. According to the Cisco, these are the nodes and they have a different specification. So first two of them are the switches, and the switches will provide you with the virtual functions, virtual network functions in order to communicate with your backend devices. Now these are first two are the 9540 switches, which are like a basic ones, and the second ones are the CSP 5444 platform, which comes with 44 CPUs, 192 GB of RAM, and high speed Ethernet ports. Sorry, gigabyte ports. All right, so this is how the device looks like as per the Cisco ones. And again, this is again the same theory with the what do we say for the service chaining, involves a single node application, single node. So these two will represent as a single node. Application traffic is directed from source WAN edge router to SD-WAN fabric to the colo edge router that provides the service. After passing through a network service such as firewall and all those things, it will go back to the destination. Both control plane and data plane policies can govern the service chaining. Doesn't matter how you process or how you push the policy, because we have used the data policies in order to achieve the service chaining. The key distinction is that data policies are transmitted from vSmart controllers to the SD-WAN routers, while the control policies remains only on the vSmart controller. So whenever you are talking about the data policy and the control policy will always stay on the vSmart, but the data policy will be pushed to the edge devices. So the results will be pushed. So what should be done? That will be pushed to the edge devices with respect to the data, but with the control policy, it will only stay on the vSmart, and vSmart is the brain of the SD-WAN, so it will steer the traffic accordingly. Now, control policies can only match on control plane identifiers, as vSmart controller do not access actual data packet. Yes, definitely, because it's just a brain and it will steer the traffic, whereas the data policies are enforced directly on the SD-WAN routers without this limitation. And this is another diagram which will depict you with the CoLocation rack. Again, it's the same thing. The only difference is that whenever the edge router is that, it is going via the L3 VPN or the MPLS or the any kind of transport going to your colo rack where there is a servers or anything, and the service is hosted over there, going through the series of the services, then going back to your destination. It's the same thing, it's just like a different way of presenting. So network services are integrated into the SD-WAN fabric through OMP, allowing for flexible service insertion with the VPN context. So definitely, because since this is your colo rack, now once your SD-WAN fabric is being connected to this colo rack, this is now being added to your OMP. So overlay management protocol, so that will be added to your SD-WAN fabric itself. So now it is now behaving like that it is a part of the fabric. Now this flexibility enables regional service insertion. So since it is been connected to the fabric, so it just you can just represent this one as a like any of your branches or maybe any of your sites simply. So once that has been added to the fabric, you can just see that particular colo rack as a service insertion like a normal site or a branch only. Now OMP advertised two distinct services, one for the trusted interface and another for the untrusted interface, ensuring traffic symmetry is maintained. So since there will be multiple interfaces connected to the fabric, so it will make sure that the traffic comes in one interface and leaves to the other interface by making one of them as a trusted one, another one as the untrusted interface. And again, how the co-location and the rack will be installed and all those things, it's entirely a different thing. It's a very, very long topic. So I'm just going with a general idea of how things might be working. That's it. Now service chaining with the multiple scenario, again you instead of having one single node, you do have the dual nodes. Now that's it, connected to your fabric, and again doing the same service chaining. Alright, so these diagrams give you more information about how things will be connected within the colo rack. Now you do have the two switches connected over here, and within two switches will be forming a single node, and that single node, within that single node you will be hosting a virtual switch. Now this virtual switch will be mapped to the virtual network functions, different functions, which will be again mapped to the VLANs. So again, it's very much complex routing within your devices. Just to make the things simple, I'm not going much into the deeper into that. All right, so this is one device and this is one device. Both of them are connected with multiple cables and they are now hosting like a port channeling over here in between. That means it's like a bundle and both of them are acting like a single device now. Since they are acting now like a single device, they will be a virtual switch hosted over here. And once any devices are connected to any of the ports, now if it is a layer 2, then it will be assigned as a VLAN IDs. So this virtual switch will have a port groups. So I'm just trying to explain it in an easy way. So don't think that those port groups are called as a virtual network functions, like, and they are acting like an adapters for you, virtual adapters, VNFs. And whenever you are connecting an interface, you will map that interface to this particular VNF and it will be assigned to that particular VLAN. So that's again how you will be mapping. If you know the virtualization, how it works, it's a similar concept will be applied over here. All right, so after that is been mapped, you have different services mapped, and after that you will perform your routing, make sure the traffic enters into it, goes to the different devices and all those things, and leave the node securely and go to its destination. So it's like this is where you are inserting your service. So you're doing the service chaining. So that's where your traffic coming in, going to different devices over here, and leaving the device. All right, so that's what with the Cisco colocation. I hope this was informative for you and thank you.